to create a superior high-retention documentary that outshines the current outlier videos, we must move beyond merely listing anomalies. We will exploit 3 specific law gaps where the current operating system of the universe isn't just malfunctioning, it is fundamentally invalid. Law Gap 1, the prerequisite failure, the Great Wall versus homogeneity. While competitors focus heavily on the universe breakers, massive early galaxies, they almost entirely ignore the Hercules Corona Borealis Great Wall, a structure that represents a scientific civil war over the very foundation of cosmology. Detailed explanation. The entire mathematical framework of modern physics, known as lambda CDM, is built upon a single, non-negotiable prerequisite, the cosmological principle. This principle assumes that the universe is homogeneous and isotropic, meaning that if you zoom out far enough, the distribution of matter is smooth and looks the same in every direction. This is not a prediction the model makes, it is the ground the model stands on. The Hercules Corona Borealis Great Wall is a filamentary structure of galaxies stretching roughly 10 billion light-years across the sky. According to the standard model, the universe is supposed to become smooth at a scale of about 1 billion light-years. The Great Wall is 10 times larger than the maximum scale allowed by the cosmological principle. If the universe is lopsided or asymmetric at this scale, the equations that produce lambda CDM, specifically Einstein's field equations, simply do not apply to this site. We are not just adjusting a model, we are realizing that the skyscraper of modern physics was built on a 45-degree slope, rendering the entire design inapplicable. By highlighting this, we shift the narrative from a measurement problem to a foundational collapse that makes our current universe invalid. Law Gap 2, the local lagoon paradox, the death of universality. Competitors treat James Webb's anomalies, the Hubble Tension and impossible galaxies, as missing ingredients or bugs in a single universal system. They miss the deeper, more unsettling law vault angle, the possibility that the laws of physics are not universal but merely local assumptions. Detailed explanation. We are currently living through what we might call the fourth zoom. Just as Copernicus showed that Earth is not the center, and Hubble showed our galaxy is not the only one, James Webb is showing us that our physical laws are not global. The local lagoon analogy is the key narrative hook. We are like marine biologists who have spent 100 years studying a single, chemically unique lagoon, assuming its properties, the 26 fundamental constants, like the speed of light or the mass of an electron, apply to a billion-mile ocean. James Webb has looked past the lagoon and found that the ocean's chemistry is different. The 26 dials of the universe appear to be fine-tuned with a precision that random chance cannot explain in a single universe. If Webb finds impossible galaxies, it isn't because the galaxies are wrong, it's because they are operating under the foreign physics of a neighbouring bubble universe, or a different patch of the multiverse. The map we've used for a century wasn't wrong, it was only ever for our street. This transforms the documentary into a philosophical thriller about simulation instability, where reality is failing its own consistency checks because the rendering engine of our local patch is different from the rest of the metastructure. Law Gap 3, the memory of the vacuum, information persistence. Competitors often mention the vacuum catastrophe as a math error, the 120 order of magnitude discrepancy, but fail to connect it to the holographic principle or the idea that spacetime is emergent. Detailed explanation. In the most elite theoretical physics circles, space is not a container, it is a consequence. According to Van Ramsdonk's 2010 thought experiment, spacetime geometry emerges directly from quantum entanglement. Entanglement is the quantum glue that holds the three dimensions together. If you remove that entanglement, the bridge between regions of space closes, and space itself stops existing. This allows us to frame the Webb anomalies as rendering artifacts. If the vacuum energy we measure is off by 120 orders of magnitude, it's because we're measuring the shadow of a deeper reality. The holographic shredder theory suggests that the universe is a system with perfect memory. Black holes are not graves, they are shredders that scramble information but preserve it on their event horizons. If space is an emergent property, then what Webb is seeing in the early universe are the seams of the projection. The impossible fossils and chemical ghosts found by Webb, elements like iron and carbon appearing far too soon, suggest that the universe was pre-packaged or re-rendered from a previous eon, as proposed in black hole cosmogenesis. We are living inside a holographic womb where the glue is being configured by a parent universe, and Webb is the first instrument sensitive enough to see the plumbing behind the wall. Narrative synthesis for the script. By exploiting these three gaps, your documentary will move from Webb found old galaxies to an existential investigation. 1. The framework is dead. The Great Wall proves the ground of our physics is lopsided. 2. The laws are local. We are marine biologists in a lagoon, realizing the 26 dials are just our local settings. 3. Space is a projection. Space-time is just the shadow cast by quantum entanglement, and we are seeing the artifacts of a previous universe bleeding into ours. This creates a related and better product by providing the deep lore and horror of scale that standard astronomy videos lack. In February 2023, a Nobel Prize winner looked at the latest data streaming back from the James Webb Space Telescope and said 4 words that no one in cosmology has been able to publicly refute since. This is not our universe. These weren't the words of a fringe theorist or a clickbait seeker. They came from John Mather, the man who spent 20 years of his life certifying the very foundation of modern physics. Mather was the primary investigator for the COBE satellite, the instrument that measured the heat left over from the Big Bang with such precision that it turned cosmology from a field of guesswork into a hard science. He didn't just propose a theory, he provided the certificate of occupancy for our reality. And now, he is the building inspector standing outside the skyscraper of modern physics, telling us the foundation has already collapsed. To understand why this is a confession rather than a critique, you have to realize that Mather isn't attacking the standard model of the universe from the outside. He built its strongest wall, and he is now admitting the structure he helped create does not match the territory we are actually looking at. The scientific community has responded to these 4 words with a specific, haunting silence. A silence more informative than any press conference or coordinated rebuttal. For decades, we believed we lived in a universe governed by a single, elegant framework called lambda CDM, a set of equations that describes everything from the first fraction of a second after the Big Bang to the ultimate fate of the stars. It worked so beautifully for so long that we began to confuse the map with the territory, treating our equations as if they were reality itself rather than a local approximation. But as the James Webb Space Telescope peels back the layers of the early universe, one photon at a time, we are discovering that the universal laws we measured for the last century might have been nothing more than local assumptions. We are like marine biologists who have spent their entire careers studying a single lagoon, mapping every current and every species with meticulous detail, only to be shown a satellite image revealing that our lagoon is a tiny, chemically unique patch of a billion-mile ocean governed by laws we never even imagined. This isn't just about a minor measurement error. It is a scientific civil war over the very soul of reality. At the center of this war is a number known as the Hubble constant, which measures how fast the universe is expanding. For years, two teams of brilliant scientists have been measuring this number using different methods, and they've arrived at two different answers that both claim to be perfectly accurate. One team looks backward 13.8 billion years to the faint glow of the Big Bang, predicting an expansion rate of 67 kilometers per second. The other team looks outward at the stars we can see today and measures a rate of 73. In any other field, a 9% discrepancy would be a minor inconvenience, but in cosmology, it is a catastrophe. If you get this number wrong, everything else downstream of it shifts. The age of the universe, the distances between galaxies, and the timeline for when life itself became possible. You aren't just adjusting a dial, you are redrawing the entire history of everything that has ever existed. The James Webb Space Telescope was sent into the deep black of space specifically to settle this argument, to act as the ultimate arbiter and reveal the correct number. The world expected Webb to gently deflate the crisis, to reveal that the discrepancy was just a calibration error or a trick of the light. But Webb did the exact opposite. It confirmed the contradiction. It showed that the 73 team was right, which means the 67 team, the one relying on our most fundamental models of the early universe, must be missing something massive. As Nobel laureate David Gross put it, we should no longer call this a tension or a problem. We must call it a crisis. But the Hubble tension is just the first crack in the load-bearing columns of our reality. As the telescope looked deeper into the cosmic fog of the early universe, it found galaxies that simply should not exist. According to our models, the first few 100 million years after the Big Bang should have been an era of small, dim, fragile structures barely flickering into existence. Instead, Webb found galaxies like JADES-GS-Z11, which exists only 330 million years after the beginning, but has already carved out a massive bubble of ionized gas 650,000 light-years across. This is the grandparents before parents paradox, finding a fully formed city in a place where we haven't even finished digging the foundation. These galaxies, nicknamed universe breakers, are running at nearly 100% star formation efficiency, a feat that violates every known physical law of how matter collapses under gravity. Standard physics dictates that only about 10% of gas in any given region actually forms stars, while the rest is blown away by radiation and heat. These early galaxies are ignoring that limit, behaving like a factory that converts every gram of raw material into a finished product with zero waste, zero defects, and zero downtime. When physicists try to adjust their models to fit these observations, pushing efficiency to its theoretical maximum or introducing exotic new particles, the gap remained. At some point, a model that requires increasingly extreme adjustments to approach a result is no longer explaining reality. It is merely desperately trying to accommodate it. However, there is an even deeper, more unsettling anomaly that the successful transcripts have largely ignored, one that points to a prerequisite failure in our entire mathematical framework. It is called the Hercules Corona Borealis Great Wall. This is a structure so vast, measuring roughly 10 billion light-years across, that its very existence violates the cosmological principle. Our entire understanding of the universe, including Einstein's equations of general relativity, is built on the assumption of homogeneity, the idea that if you zoom out far enough, the universe looks the same in every direction. But this great wall is 10 times larger than the scale at which the universe is supposed to be smooth. If the universe is lopsided or asymmetric at this scale, then the ground we built our physics on isn't flat, it's a steep slope. You don't just modify a skyscraper when you find out the foundation is sitting on a 45-degree angle. You realize the entire design was never applicable to this site at all. This structure suggests that our observable sphere is not a representative sample of the whole, but a unique, perhaps even anomalous, patch of a much larger metastructure. We have been operating with a map of the continent while standing on a single street corner, assuming the rules of the sidewalk apply to the entire world. This leads us to the most provocative question of all. Is reality failing its own consistency checks? Some within the community have begun to whisper about simulation instability or multiverse bleed, speculating that Webb is not seeing impossible objects, but rather the rendering artifacts of a reality that is more complex than a single Big Bang. If the physical constants we have measured for a century are actually local values rather than universal laws, then the "Not Our Universe" headline isn't an exaggeration. It's a literal description of the fact that we have been living inside a local exception to a much stranger global rule. We have reached the boundary of what our current tools can explain. The cracks are not just at the edges, they are in the 4 load-bearing walls of our cosmological model. The Hubble Tension, the impossible galaxies, the large-scale asymmetry of the Great Wall, and the evolving nature of the dark energy that drives it all. Each of these signals, taken alone, might be manageable, but collectively they point toward a single, unavoidable conclusion. Something in our description of the universe is fundamentally incomplete. We are the species that built a $10 billion mirror to look at the beginning of time, only to find that the beginning does not match the model we wrote for it. We are living inside a question that is too beautiful to leave unanswered, standing at the edge of the 4th zoom, where we finally realize that our laws are not universal, they are just local. This is the beginning of the cosmic crime scene investigation. We aren't just looking for a missing variable, we are looking for a missing reality. The old answer is officially insufficient, and the new answer hasn't arrived yet. We are in the uncertainty, the gap between the map we drew and the territory that is refusing to follow it. As we follow the data through the physics that breaks and the mathematics that won't close, we have to ask ourselves, what if the universe isn't broken? What if our understanding is? This is chapter 1 of the final reckoning, and the silence from the stars is only getting louder. Imagine a geologist digging through a layer of sediment known to be 100 million years old, only to find a fully functioning modern smartphone encased in the rock. This is the exact sensation felt by the astronomical community when the James Webb Space Telescope transmitted the data for a galaxy known as JADES-GS-Z11. It sits in a slice of time just 330 million years after the Big Bang, a period when the universe was supposed to be a dark, chaotic nursery of neutral hydrogen. According to every simulation built in the last 30 years, we should be seeing infant structures, fragile, dim, and disorganized clumps of matter barely flickering into existence. Instead, JADES-GS-Z11 was found shining with an intensity that should have been physically impossible for its age. It was not just present, it was defiant, emitting enormous amounts of ultraviolet radiation that signaled a level of maturity our models reserved for galaxies billions of years older. The mystery of this galaxy goes deeper than its mere existence. It is about the bubble it shouldn't have been able to build. In that early epoch, the universe was filled with a thick cosmic fog of neutral hydrogen that absorbed and scattered light. For light to travel across the cosmos, the first stars had to clear this fog through a process called reionization, which was expected to take hundreds of millions of years. Yet JADES-GS-Z11 had already carved out a massive bubble of ionized gas stretching 650,000 light-years in every direction. This is a prerequisite failure on a cosmic scale, suggesting that the fog was either cleared much faster than physics allows, or that the timeline we've been using is fundamentally broken. As astronomer Kevin Heinlein put it with unsettling simplicity, we shouldn't have found a galaxy like this at all. This brings us to the universe breakers, a nickname coined by Mike Boylan-Colchin to describe these impossible fossils. His analysis revealed a terrifying mathematical reality. For these galaxies to be as massive as they appear so early in time, they would have had to convert nearly 100% of their available gas into stars. In our current universe, and according to every law of fluid dynamics we understand, that efficiency limit sits at a hard 10%. Stars are violent births. The radiation pressure and supernova shockwaves from the first stars should blow the remaining gas away, naturally suppressing further star formation. To reach the masses Webb is seeing, these galaxies would have to behave like a factory that converts every single gram of raw material into a finished product with zero waste, zero defects, and zero downtime. Physics, as we have written it, simply does not work that way. When these universe breakers first appeared in the data, the scientific community scrambled to find a spotlight that might be deceiving us. The leading theory was that these weren't massive galaxies at all, but little red dots, compact objects, where a single, supermassive black hole was devouring gas so hungrily that the friction created a glare equivalent to 1 billion suns. This flashlight taped to a candle effect could inflate a small galaxy's apparent size, making it look 10 times more massive than it truly was. And in some cases, this correction worked, bringing certain candidates back into the fold of the Standard Model. But even after these deceptive objects were removed from the census, the problem remained. The early universe still contains roughly twice as many massive galaxies as the Standard Model allows, and some of them have a layered complexity that points toward a broken timeline. The most haunting piece of evidence for this broken timeline is a structure nicknamed the Big Wheel. It is a massive spiral galaxy discovered within the first 2 billion years of the universe. To a cosmologist, a spiral structure is the grey hair of a galaxy. It represents a state of maturity and calm that takes billions of years of orderly rotation to achieve. The early universe was supposed to be a demolition derby of violent mergers and chaotic accretion, a place where galaxies were irregular, clumpy, and turbulent. Finding a perfectly settled spiral like the Big Wheel in that era is like finding a pristine Victorian mansion in the middle of a construction site where the workers haven't even finished pouring the concrete. It suggests that either these galaxies assembled their mass in an unusually neat way that skips the violent adolescence predicted by our models, or our clock for the universe's birth is off by billions of years. This leads us to the most unsettling deep law possibility. The idea that we are not seeing impossible objects, but rather foreign physics. This is the multiverse bleed theory, which suggests that Webb may be peering into regions where the physical constants, the 26 dials that define our reality, are set slightly differently. If the speed of gravity or the rate of matter collapse is higher in these distant patches, then universe breakers are no longer impossible. They are simply the natural result of a different set of rules. We have spent a century assuming that the laws we measured in our local lagoon apply to the entire infinite ocean of the cosmos. But if Webb is showing us that the map was only ever for our street, then the phrase "this isn't our universe" becomes a literal description of our new reality. As we look at these impossible fossils, we are forced to confront the detective mystery at the heart of the JWST mission. What if the Big Bang was not the absolute beginning, but a big bounce or a bridge from a previous eon? Nobel laureate Sir Roger Penrose argues that the remnants of a previous universe might be lingering in our skies, and the rapid growth we see in these early galaxies might be the result of re-rendering information that existed before our time began. These galaxies are not just points of light, they are the fingerprints of a process that defies the linear story of the Standard Model. We are like investigators standing over a crime scene where the evidence contradicts the witness statements. The witnesses, our old equations, say the universe is 13.8 billion years old, but the evidence, the Big Wheel, and JADES-GS-Z11 says the timeline has been misread. The Standard Model, Lambda-CDM, has been the operating system of cosmology for 3 decades, and it has worked with suspicious precision until now. But an operating system failure doesn't always look like a total crash. It starts with a few programs making requests the system wasn't built to handle. Webb is that program. It is asking for galaxies at the wrong masses and the wrong levels of maturity, and the operating system is failing the test. We are currently in the fracture stage, where every attempt to patch the model by adjusting parameters only creates more tension elsewhere. If we push star formation efficiency to 100%, we break the laws of thermodynamics. If we change the age of the universe, we break our measurements of the oldest stars. We are living through what scientists call a crisis, a word that has officially replaced tension in the literature. It is a moment where the map versus territory discrepancy has become too large to ignore. We built a $10 billion mirror to see our origins, and that mirror is reflecting a horror of scale, the possibility that our most fundamental laws of physics are merely local assumptions. If these impossible fossils are real, then the universe is not just stranger than we imagine. As Arthur C. Clarke once said, it is stranger than we can imagine, because it is refusing to follow the rules we wrote for it. But as we peel back the layers of these galaxies, we find something even more disturbing than their mass or their structure. The light they emit is chemically specific, containing the fingerprints of elements that have no business existing in a young universe. Carbon, oxygen, and iron are not primordial. They are the products of stellar death, fused in the hearts of stars that lived and died before these galaxies were even born. This is the chemical ghost mystery, the discovery that the early universe is already polluted with the ashes of ancestors that the official timeline says hadn't even been born yet. We are finding a layered complexity that takes millions of years to form in a sediment that is supposed to be fresh. To solve the mystery of the universe breakers, we have to stop looking at how much they weigh and start looking at what they're made of, because the chemicals in their stars are about to tell us that we aren't just in the wrong universe, we're in the wrong time. To truly understand the depth of the crisis, you have to look past the sheer size of the galaxies James Webb has discovered and look instead at what they're made of, because the light travelling across 13 billion years of void carries more than just an image. It carries a chemical confession. When we look at a distant galaxy, we aren't just seeing a smudge of light. We are reading a barcode encoded in the wavelengths it absorbs and emits, a technique known as spectroscopy that allows us to identify individual elements with forensic precision. In our local neighbourhood, this chemical reading is predictable. Old stars are rich in metals, which to an astronomer means anything heavier than hydrogen and helium, while the oldest, most primitive stars are chemically pure, containing only the raw ingredients left over from the Big Bang. But the James Webb Space Telescope has just performed a chemical audit of the early universe, and the results have surfaced what we must call the chemical ghost mystery. Webb has peered into structures that existed just 400 to 500 million years after the beginning of time, and found the distinctive fingerprints of carbon, oxygen, and iron. To the average observer, this might sound like a minor detail, but to a physicist, it is a haunting impossibility. These elements are not primordial. They are not forged in the heat of the Big Bang. Carbon, oxygen, and iron are manufactured exclusively in the crushing nuclear hearts of stars over millions of years of nuclear burning, and they're only scattered into the surrounding gas when those stars die in violent supernova explosions. That scattered, polluted material must then collapse into a second or even third generation of stars, which are then born chemically richer than their ancestors. This process, known as nucleosynthesis, has a pace set by the laws of nuclear physics, a pace that chemistry cannot override. Finding these heavy elements in the first few 100 million years of the universe is like finding a burnt-out cigarette in a room that was supposedly sealed the moment the building was completed. It implies a history that the official timeline simply has no room for. This creates what we call the grandparents before parents paradox. You cannot inherit a library from ancestors who have not yet been born, and you cannot build a chemically complex galaxy from materials that have not yet been quarried. The chemical complexity Webb is detecting requires multiple cycles of stellar birth and death to have already occurred, meaning entire generations of stars must have lived, exhausted their fuel, and exploded before the galaxies we are observing even had time to form. We are seeing a layered complexity that normally takes billions of years to accumulate, but it is appearing in a slice of time where the universe is still in its infancy. As the Nobel laureate Adam Ree noted, this isn't just a measurement error. It suggests we have fundamentally misunderstood the timeline of the universe. Think about it through the lens of a river delta. A delta forms over tens of thousands of years as sediment accumulates, channels shift, and the system reaches its characteristic, intricate structure. The layers at the bottom record the beginning, and the layers at the top record the present. Now imagine a geologist finding a river delta where the deepest sediment is only 500 years old, yet the delta possesses the layered complexity and mineral diversity of something 10,000 years in the making. The layers are real and the dates are real, but the timeline connecting them is a physical impossibility. This is the chemical situation Webb is documenting in the early universe. The complexity is there, but the time required to produce it is missing. This leads us to a deeper, more unsettling realization. The mass problem and the chemistry problem share the same broken root: time. If the early universe is already polluted with heavy elements and filled with massive mature galaxies, then our 13.8 billion year clock is not just slightly off. It is potentially a local illusion. The broken timeline theory suggests that our cosmic expansion assumptions are incomplete, and that matter clumped and evolved much faster than the standard model lambda CDM could ever predict. We have been operating with an incorrect timeline for decades, assuming that the slow, orderly pace of evolution we see in the modern universe was the same pace that governed the beginning. But Webb is showing us that the cosmic fog was cleared, and the chemical library was written at a speed that violates our current understanding of gravity and nuclear transition. The implications take us into the realm of deep lore that the original documentaries were too afraid to touch. If the chemistry of the early universe is too old, where did those heavy elements come from? One speculative but mathematically grounded theory comes from Nobel laureate Sir Roger Penrose, who argues that we live in a universe of infinite cycles, a sequence of eons where one universe's remote future becomes the Big Bang of the next. In this view, the impossible chemicals Webb is seeing aren't from our universe at all. They are the chemical ghosts or remnants from a previous eon, carried across the bridge of a big bounce into our own reality. These elements might be the last whispers of a previous cosmos, quietly etched into the sky. Another possibility, even more jarring, is the multiverse bleed theory. If our universe is just one bubble in a vast self-reproducing multiverse, the 26 dials of physics, the constants that determine the speed of light and the strength of gravity, might vary across cosmic boundaries. We may be observing regions influenced by neighbouring bubble universes where the physical constants were set slightly differently, allowing stars to live and die in the blink of an eye compared to our local rules. This would mean the telescope is not seeing impossible objects, it is seeing foreign physics bleeding into our view. It would confirm the title's most haunting claim. This truly isn't our universe, in the sense that our local laws do not apply globally. What makes this chemical evidence particularly hard to dismiss is that it does not rely on a single, debatable technique. Mass estimates of galaxies use photometry, measuring total brightness, which can sometimes be fooled by little red dots or hungry black holes masquerading as massive star populations. But chemical abundances use spectroscopy, a direct measurement of atomic transitions that is much harder to fake. Two independent lines of evidence, measured by different instruments and interpreted through different techniques, are pointing at the same impossibility. One crack in the wall of physics is a question. 4 cracks in the load-bearing columns of the same building are a verdict. As we process the data, the silence from the scientific community regarding these chemical ghosts is deafening. They're using careful language like challenging our current understanding and difficult to reconcile. But what they're really saying is that the map has failed. We've reached the edge of what our current tools can explain. If these galaxies are chemically mature, they are survivors of a history we haven't written yet. We are the species that built a $10 billion mirror to look at the beginning of time, only to find that the beginning was already crowded with the ashes of an even earlier past. The presence of carbon and iron in the first 300 million years isn't just an anomaly. It is a signpost pointing toward a fourth zoom in our understanding. Just as Copernicus showed us that Earth was not the center, and Hubble showed us that the Milky Way was just one of many, Webb is now showing us that our universal timeline is likely just a local approximation. We are living inside a question that is too beautiful to leave unanswered, standing in a universe that is chemically too old to be ours. The next chapter of this investigation isn't about how galaxies grow, it's about the vacuum catastrophe and the invisible energy that is tearing this impossible timeline apart. The chemical ghosts are just the beginning. The real terror of scale lies in the energy we cannot see, but which Webb is finally forcing us to confront, to understand the true depth of the crisis currently unfolding in our sky. We have to look past the impossible galaxies and the broken timelines and stare directly into the most terrifying number in the history of science. We have to confront the fact that the very vacuum of space, the nothing that makes up the vast majority of our universe, is hiding a mathematical error so profound it has earned the title of the vacuum catastrophe. This is not a minor disagreement between two teams of researchers, or a slight calibration error in a gold-plated mirror. This is a discrepancy of 120 orders of magnitude, a 1 followed by 120 zeros, representing the largest failed prediction in the history of human thought. To put the sheer scale of this failure into perspective, there are only 10 to the 80 atoms in the entire observable universe. We are not just missing a variable or a decimal point, we are missing the very foundation of reality, and the James Webb Space Telescope has just confirmed that the placeholder name we've been using to hide this gap is finally starting to peel off. The story of this catastrophe begins with the realization that empty space is never truly empty. According to the laws of quantum field theory, our most successful description of the very small, the vacuum is a simmering soup of activity where virtual particles pop in and out of existence, borrowing energy from the void before instantly annihilating. This zero-point energy is not a theoretical ghost. We have measured its physical pressure in laboratories through the Casimir effect, proving that the vacuum itself has a weight. Because energy has mass and mass exerts gravity, this boiling quantum sea should exert a massive outward pressure on the fabric of the universe, a value represented in Einstein's equations by the Greek letter lambda. When physicists use quantum mechanics to calculate how much of this energy should exist in a single cubic centimeter of space, they get a number so gargantuan that the universe should have exploded into total dissipation in the first trillionth of a second. Yet when we use the James Webb Space Telescope to measure the actual expansion of the cosmos, we find that the real value of this energy is almost zero. It is 0 point, followed by 121 zeros, and then a 1. This 120 order of magnitude gap is the moment where the two pillars of modern physics, quantum mechanics, and general relativity stare at each other and realize they are describing two different universes. One sees a mountain of energy that should shred the cosmos, while the other sees a tiny grain of sand that allows galaxies to form and stars to shine. For 25 years, we have hidden this fundamental incompatibility behind a single, elegant phrase, dark energy. We must be honest about what that name actually signifies in this new era of discovery. Dark energy is not a physical discovery, but a linguistic mask for a phenomenon we can measure and name, but fundamentally cannot explain. It is the name we give to the 95% of reality that is essentially dark to our instruments, a placeholder for a vacuum that refuses to behave according to the math we wrote for it. The stakes of this placeholder reality are total, because every serious model of how the universe ends is built on assumptions about what this vacuum energy does over trillion-year timescales. For decades, the standard model lambda CDM treated this energy as a cosmological constant, a fixed, unchanging pressure woven into the very fabric of space-time. We assumed that if the value of lambda was fixed, we could predict the ultimate fate of everything that exists. We mapped out a future of heat-death, where the universe expands forever at a steady rate until every star burns out and the cosmos becomes a cold, dark, thermodynamically exhausted void. But in early 2025, the Dark Energy Spectroscopic Instrument, or DESI, released a census of 6 million galaxies that sent a tremor through the field. The data suggested that the constant we relied on is not constant at all. The influence of dark energy appears to be weakening as the universe ages. If dark energy is evolving rather than fixed, then our projections for the end of the universe are not just slightly off, they are a total fantasy. We are like a structural engineer who calculates the lifespan of a bridge, assuming the steel maintains a fixed tensile strength across all temperatures, only to discover that the steel's properties are slowly drifting. If the steel of our vacuum is changing, then the trajectory of the entire cosmos shifts. If dark energy were to strengthen in the future, it would lead to a big rip, where the expansion becomes so violent it shreds galaxy clusters, then solar systems, and finally individual atoms in a final moment occurring faster than the speed of light. If it continues to weaken and eventually reverses, we face the big crunch, where the universe collapses back in on itself in a violent mirror of the Big Bang. The DESI data does not yet select the final ending, but it has officially selected instability, revealing that the most precisely measured number in cosmology is standing on shifting sand. This instability points toward the deep law angle of simulation instability, a theory gaining traction in futurist circles as Webb continues to surface anomalies that the standard model cannot reconcile. If our measurements of the vacuum are off by 120 orders of magnitude, and the energy we call dark energy is drifting in ways our physics didn't predict, we must consider whether we are seeing the rendering artifacts of a reality that is failing its own internal consistency checks. We are the species that built a $10 billion mirror to find the truth, only to discover that the universal laws we measured for a century were merely local assumptions that apply to our specific patch of the cosmic lagoon. This is the horror of scale. We're beginning to realize that the laws of physics are not like the rules of arithmetic, which are universal and necessary, but perhaps more like the rules of chess, contingent, local, and set by a mechanism we have yet to identify. This leads us to the mystery of the 26 dials of the universe. There are 26 fundamental constants: the speed of light, the mass of the electron, the strength of the electromagnetic force, and the cosmological constant that appear to be fine-tuned with a precision that random chance cannot explain. If you change the strength of the vacuum energy by just 1 part in 10 to the 60, the universe would have either collapsed or expanded too fast for a single star to ever ignite. We live in a universe that arrived with its combination lock already dialed in to the exact values required to permit complexity. To explain this coincidence without invoking a creator, scientists have been pushed toward the multiverse bleed theory, the idea that our universe is just one bubble in an infinite, self-reproducing multiverse where every possible combination of these 26 dials is tried. In this view, we only observe a life-permitting universe because we are the kind of things that can only exist in a life-permitting patch of the ocean. The James Webb Space Telescope was not sent out to find the multiverse, but the data it is returning is making the single universe model increasingly difficult to defend. When we see galaxies that matured too fast and a vacuum that weighs almost nothing despite the quantum storm inside it, we are seeing the seams of our specific bubble. We are standing at the edge of what we call the fourth zoom, a realization that just as Copernicus showed us Earth was not the center and Hubble showed us the Milky Way was not the only galaxy, Webb is now showing us that our physical laws are not universal. They are the local maps for our street corner of a metastructure so vast that our entire observable sphere is just a single drop in a billion-mile sea. This realization transforms the vacuum catastrophe from a math problem into a philosophical reckoning. We've spent decades treating dark energy as a solved variable because the equations worked, but we confused the success of the equation with an understanding of what produces it. Now that the constant is drifting and the impossible galaxies are staring back at us, the silence from the scientific community is the sound of a paradigm shifting. We are the species that named the darkness so we wouldn't have to fear it. But the mirror is now showing us that the darkness is far more active and wrong than our labels ever allowed. We are currently living inside the fracture, the period between when the old answer is known to be insufficient and the new answer has not yet arrived. The 120 order of magnitude gap is the shredded document of our reality. For years, we believed the vacuum destroyed information about its true nature, but the anomalies Webb is finding are like the pile of strips left by a shredder, scrambled, difficult to read, but in principle, recoverable if we have the courage to redraw the map. This is why the "Not Our Universe" headline is not a metaphor. It is a literal description of the fact that we have been living inside a local exception to a much stranger global rule. The placeholder name dark energy is finally beginning to peel off, and what lies beneath it is not a constant, but a dynamic, evolving force that determines the fate of everything that has ever existed. As we trace the drift of this energy and the impossible structures it allows, we have to ask ourselves, what if the universe isn't broken? What if our understanding is? The vacuum catastrophe is the final signal that the standard model has been extended beyond the range it was ever tested in, and it is failing precisely where it was most confident. We are not watching a failure of science, we are watching science operate at the ultimate boundary of what it can know. We are the species that built a $10 billion eye to look at the beginning of time, only to find that the beginning does not match the model. We are living inside a question that is too beautiful to leave unanswered, standing at the threshold of a reality that is bigger, older, and far more ununiversal than the picture on the box. This is the end of the 120 order of magnitude delusion and the beginning of the great cosmic reckoning. To truly understand the depth of the current crisis in cosmology, we must look past the individual stars and the impossible galaxies and examine the very fabric upon which they are stitched. For the most foundational assumption of modern science is currently being shredded by a structure so vast it shouldn't exist in our reality. For over a century, every equation we have written and every simulation we have run has been based on a single, elegant prerequisite known as the cosmological principle. This principle is the contract we signed with the universe, an agreement that if we zoom out far enough, the cosmos is homogeneous and isotropic, meaning it looks the same in every direction and has the same density of matter no matter where you stand. This is the level ground upon which the entire skyscraper of lambda CDM was built, a mathematical necessity that allows us to treat the entire universe as a single, unified system. But as our instruments have improved, we have discovered a slope in the foundation that is too steep to ignore, a structure known as the Hercules Corona Borealis Great Wall. This Great Wall is a filamentary structure of galaxies and dark matter that stretches for approximately 10 billion light-years across the observable sky. To put that number in perspective, the entire observable universe is roughly 93 billion light-years across, meaning this single structure spans more than 10% of the total diameter of everything we can see. According to the standard model, the universe is supposed to become smooth at a scale of about 1 billion light-years, where the clumping of matter averages out into a uniform cosmic web. The Hercules Corona Borealis. Great Wall is 10 times larger than the scale at which the universe is supposed to be homogeneous, a direct violation of the very principle that makes our physics possible. This isn't just a large object, it is a scientific civil war in physical form, because if the universe is lopsided or asymmetric at this scale, then the ground we built our physics on isn't flat, and the entire design of our cosmological model may be inapplicable to the reality we are actually observing. Think about an architect who is commissioned to design the tallest skyscraper in human history. Every load-bearing calculation, every foundation depth, and every distribution of stress is computed on the absolute premise that the ground beneath the building is perfectly level. Now imagine that as the building reaches halfway to the clouds, the architect discovers that the ground isn't just slightly uneven. It is a steep 45-degree slope, where the foundation on one side sits 10 meters lower than the other. You do not simply modify the skyscraper or add a few extra bolts to the steel beams in such a scenario. You realize that the entire design was never applicable to this site at all. Lambda CDM is that skyscraper, and the Hercules Corona Borealis Great Wall is the slope that proves we are building on a false foundation. The mystery of this lopsided cosmos has created a quiet terror within the scientific community, leading some to whisper that the title, "This Isn't Our Universe," is not a provocation, but a literal description of our current state. For decades, we have assumed that our observable sphere was a representative sample of the whole, a local lagoon that reflected the chemistry and laws of the entire infinite ocean. But the discovery of structures like the Great Wall suggests that we may be observing only one unique, perhaps even anomalous patch of a much larger and more complex metastructure. We have been like marine biologists who have spent their entire careers studying a single tide pool, mapping its currents and species with meticulous detail, only to be shown a satellite image revealing that their pool is a chemically unique exception in a billion-mile sea governed by forces they never imagined. This is where the horror of scale truly begins to take hold of the narrative. If the cosmological principle is wrong, it means our laws of physics are not universal, but local assumptions that we have incorrectly extended to the entire cosmos. We are currently living through what we might call the fourth zoom in the history of human understanding. Step 1 was Copernicus realizing that Earth moves around the Sun, which gave us Newtonian mechanics. Step 2 was Hubble realizing the Milky Way was just one of 2 trillion galaxies, which gave us the expanding universe. Step 3 was the assumption that our location was not privileged, which gave us the standard model. But step 4 is happening right now, as we realize that our laws are not universal, they are local. At this new magnification, the universe itself is the house, and what it sits inside is the question the zoom has opened. The evidence for this asymmetry is not limited to the Great Wall alone. It is a pattern of anomalies that collectively point toward a broken reality. We see impossible galaxies in the early universe that matured too fast, a Hubble tension that suggests space is expanding at different rates depending on where you look, and a dark energy that appears to be drifting rather than remaining constant. In isolation, each of these results might have a mundane explanation, but an air crash investigator knows that when the engine, the instruments, and the radio all fail on the same flight, you don't look for 3 separate problems. You look at the conditions the aircraft was operating in. The anomalies we are seeing are 3 failures on one flight, and the environment they share is a cosmological model that has been extended far beyond the range it was ever tested in. This leads us to the most provocative theory in the deep lore of the James Webb mission, the idea of multiverse bleed. If our universe is just one bubble in an infinite self-reproducing multiverse created by eternal inflation, then the 26 dials of physics, the constants that determine the strength of gravity and the speed of light, might be set differently in every patch. In this view, the Great Wall isn't just a large structure. It might be a scar or a dent left by a collision with a neighbouring bubble universe in the first moments of time. We see a cold spot in the constellation Eridanus that standard models cannot explain. A feature that several research groups have noted is consistent with the signature of a bubble collision. It is a temperature profile etched into our sky, a physical mark of a physics we will never access, and a reality running on constants we will never measure. If we accept that the Great Wall violates the smoothness of the universe, we are forced to reconsider what universal even means. We are the species that built a $10 billion mirror to find the truth, only to discover that the universal laws we measured for a century were merely the local maps for our street corner. Just as a cartographer might spend 40 years mapping a single continent with extraordinary precision, only to realize it is one landmass among 7 in an ocean he never measured, we are realizing that lambda CDM is the map of our continent, but it tells us nothing about the ocean beyond. The map was not wrong, but it was local, and the James Webb Space Telescope is the first satellite image showing us how small our continent truly is. The implications for our future are existential, because every serious model of how the universe ends, the Big Rip, the Big Crunch, or heat death, is based on the assumption that our local variables are universal constants. If the steel of our vacuum energy is drifting, and the ground of our matter distribution is lopsided, then the trajectory of the entire cosmos shifts into a territory we cannot reliably predict. We were writing the final chapter of the universe based on a fixed compass that we now know is drifting, and every calculation made to project the ship's future position is now wrong by an amount proportional to how much that drift matters. We are not just adjusting a model, we are reconsidering whether the very concept of a single, unified cosmic history is valid. As the data continues to arrive, the silence from the scientific community regarding the Hercules Corona Borealis Great Wall is the sound of a paradigm shifting in real time. They are using careful language, like challenging our current understanding, but what they're really saying is that the operating system of cosmology has crashed. The OS was not built to handle a request like a 10 billion light-year wall, and the crash doesn't look like a total failure, but a series of programs, from early galaxies to expansion rates, all failing their consistency checks at once. We are currently living inside the fracture, the period between when the old answer is known to be insufficient and the new answer has not yet arrived. We must ask ourselves the final haunting question provided by the evidence. What if the universe isn't broken, but our understanding is? What if the lopsided cosmos is the first clear signal that we are not living in the center of a perfect uniform design, but in a small chaotic patch of a much larger and more terrifying metastructure. We are the species that notice the silence of the stars and the great filter ahead of us. And now we are noticing that even the ground we stand on is shifting. The Great Wall is not just a collection of galaxies, it is the boundary of our knowledge, the point where our map of the lagoon meets the infinite, lopsided ocean. We are living inside a question that is too beautiful to leave unanswered, standing at the edge of a fourth zoom that will eventually redraw the entire picture of reality. The next version of the map, whenever it arrives, is going to be stranger and more beautiful than anything we have drawn so far, because it will finally account for the seams and the slopes that Webb is revealing. We are no longer before the revolution, unaware that one is coming. We are inside the uncertainty, with enough understanding to see the shape of the problem clearly, and not yet enough to see the shape of the answer. The lopsided cosmos is the final proof that this isn't the universe we thought we lived in, and as we follow the photons from 10 billion light years away, we are beginning to see the exact shape of everything we have yet to learn. This is the end of the homogeneity delusion, and the beginning of the great cosmic reckoning. If you look toward the constellation Eridanus, you are staring at a void that should not exist. Deep within the ancient relic radiation of the cosmic microwave background, the thermal echo of the Big Bang itself, there is a feature that has haunted cosmologists for decades. It is known as the cold spot, a region of space so vast, so unnervingly empty, and so significantly colder than the surrounding sky that it defies the most basic laws of the standard model. In a universe that is supposed to be smooth and homogeneous, the cold spot is a 500 million light-year-wide bruise on the face of reality. Statistical models suggest there is only a 2% chance that a structure this anomalous could occur by accident in a single universe scenario. But as the James Webb Space Telescope begins to surface impossible galaxies and broken timelines, we are forced to consider an explanation that was once the territory of science fiction. The cold spot isn't a void at all, it is a scar from a collision with another universe. This is the multiverse bleed theory, a speculative but mathematically grounded framework that suggests our universe is not the total sum of existence, but merely one bubble in a vast, self-reproducing multiverse. This isn't just a philosophical provocation, it is a direct consequence of the physics of cosmic inflation. When we built the standard model to explain why the sky looks so smooth, we accepted a mechanism called eternal inflation, which posits that the rapid expansion of the early universe never actually stops everywhere at once. Instead, it stops locally in small patches, while the space between those patches continues to inflate at exponential speeds. Our universe is simply one of those patches, a single bubble of stability in an infinite, boiling ocean of energy. But if space is filled with an infinite number of these bubble universes, they must eventually bump into each other. When two bubbles expanding through an inflating background intersect, the collision deposits an enormous amount of energy on their shared boundary. This energy leaves a permanent mark, a circular feature in the sky with a specific temperature profile, a central depression surrounded by a ring of relative warmth. This is exactly the signature several research groups have identified within the cold spot. It is a dent in our car, a physical mark of a physics we will never access, and a reality running on constants we will never measure. This is where the James Webb Space Telescope transforms this from a niche CMB anomaly into a central crisis of modern physics. If we are truly living in a bubble among many, then the 26 fundamental constants of nature, the dials that determine the speed of light, the mass of the electron, and the strength of gravity, might not be universal laws. They are merely the local values that our specific patch drew when inflation ended here. In other bubble universes, those dials are set differently, and we are now seeing the first evidence that these foreign rules are bleeding into our own sky. When Webb observes impossible fossils like JADES-GS-Z11, galaxies that formed far too fast and grew far too massive, it might not be seeing a failure of our star formation models. It might be seeing foreign physics. If our universe is interacting with a neighbouring bubble where the rate of matter collapses higher or the strength of gravity is slightly more intense, then the universe breakers are no longer impossible. They are the natural result of a different set of rules bleeding across the boundary where the two bubbles intersect. We have spent a century assuming that the laws we measured in our local lagoon apply to the entire infinite ocean, but Webb is showing us that the map was only ever for our street. The horror of scale in this chapter is the realization that we are living inside a region of physics that cannot verify its own universality. We are like marine biologists who have spent their entire careers studying a single tide pool, only to find a chemical signature in the water that could only have come from a billion-mile sea they have never seen. The cold spot is the physical proof that our lagoon has a leak. It is a point where the cosmic fog of our local physics meets the ocean of the multiverse, and the results are rewriting everything we thought we knew about our origins. To many, the multiverse is an outrageous idea, as Nobel laureate Sir Roger Penrose has noted, yet it is a mathematical side effect of the very theories we used to prove the Big Bang. We didn't go looking for the multiverse. We opened the wall of reality to fix a specific problem with the smoothness of the sky, and we found a second plumbing system already running behind it. The cold spot is the most visible leak in that system. It is a temperature number, a spatial location, and a statistical profile that standard inflationary models cannot explain by chance, but which a bubble collision explains perfectly. As Webb continues to peer into the deep past, it is finding a universe that is lopsided and asymmetric, supporting the idea that the cosmological principle, the idea that the universe is the same everywhere, is a local illusion. If we are part of a larger meta-structure, then the lopsided growth of galaxies and the anomalous voids in our sky aren't errors. They are the seams of our bubble. We are observing the limits of our own reality. What does it mean to do physics knowing the sample size is one? What does it mean that the foundational assumption of cosmology, that laws discovered locally apply globally, is exactly what the multiverse undermines? The title, "This Isn't Our Universe," becomes literal here. It means the universal laws we wrote were actually just local descriptions of a single bubble. We are the species that built a $10 billion mirror to look at the beginning of time, only to find the scar of another beginning that happened next door. The cold spot and the multiverse bleed theory represent the fourth zoom in human understanding. We have moved from a flat Earth to a solar system, from a solar system to a galaxy, from a galaxy to a universe. And now we are zooming out one last time to see the universe itself as a single, unremarkable bubble. At this magnification, the impossible fossils and the vacuum catastrophe are not crises to be solved, but the natural consequences of a reality that is far more interconnected and far more terrifying than the one we drew on our first maps. We are standing at the edge of the uncertainty, staring at the dent in our reality, and realizing for the first time that we are not alone in the void. The silence of the cold spot is the loudest evidence we have that the story of our universe is just one chapter in a book of infinite size. We have reached the point in our cosmic investigation where we must confront the most terrifying residents of the deep past, the monsters that were born before the light. As the James Webb Space Telescope peeled back the curtain on the first few 100 million years of time, it didn't just find impossible galaxies. It found supermassive black holes with the mass of 1 billion suns sitting in a slice of history where they should have been nothing more than microscopic seeds. To understand why this is a detective mystery of the highest order, you have to understand the speed limit of a feast. A black hole cannot simply swallow an entire galaxy in a single afternoon. Gravity may be a bottomless pit, but the act of falling in creates a friction so intense that it generates a blinding outward pressure known as the Eddington limit. This limit acts as a cosmic choking hazard where the light produced by a black hole's meal actually pushes the rest of the food away. According to every model we possessed before Webb, growing a black hole to the size of 1 billion suns should take billions of years of steady, uninterrupted feeding. Yet Webb is staring at these giants less than 500 million years after the Big Bang, fully formed, gargantuan, and utterly defiant of the standard clock. This discovery has breathed life into one of the most obscure and viral theories in the Lore Vault, the theory of black hole cosmogenesis. The horror of scale here is not just that these black holes are big, but that they might be the very reason we exist at all. This theory suggests that our universe was not a random explosion from a point of nothingness, but rather a baby universe born inside a parent black hole. In this framework, the Big Bang was not the beginning of time, it was the moment a singularity in a higher universe reached a critical density and blossomed into a new three-dimensional space on the other side. If this sounds like science fiction, you haven't looked at the math of Jacob Bekenstein and Stephen Hawking, who discovered in the 1970s that a black hole's information, its entropy, is not stored in its volume, but on the surface area of its event horizon. This is the holographic principle, the idea that the entire three-dimensional reality of a black hole's interior is actually a projection of two-dimensional data etched onto its shell. When Webb found these impossible early black holes, it provided the first physical evidence that our universe might have been pre-packaged. If we live inside a parent black hole, then the universe breakers Webb is seeing are not growing too fast. They are simply inheriting the structure and density of the parent universe. We are like the data on a hard drive that has been copied from an older, larger machine. This explains the little red dots, those compact, intensely bright objects that Webb found in the early universe. While some astronomers tried to dismiss them as measurement errors, where a black hole was simply masquerading as a galaxy. The deeper law suggests these are the umbilical cords of our reality. They are the points where the information from the parent universe is being re-rendered into our own. The black holes didn't have to grow for billions of years because they were born with their masses already dialed in by the singularity that created us. This shifts the entire documentary from a story of astronomy into a cosmic crime scene investigation. If our universe is a child universe, then the Big Bang was a birth, and the impossible maturity we see in the early galaxies is a genetic trait passed down from a previous eon. We are seeing a layered complexity that normally takes billions of years to accumulate because that complexity already existed in the parent cosmos. We are finding a library where the books were already written before the building was finished. This is the forbidden theory that the mainstream transcripts were too afraid to touch. The idea that we are not the first or the only, but a single link in a chain of black hole cosmogenesis that stretches back through an infinite hierarchy of realities. The implications of this are existentially haunting. If space-time geometry is not fundamental, but emerges from quantum entanglement, the quantum glue of reality, then a black hole is not just a grave, but a shredder that preserves the memory of everything it consumes. When matter falls into a black hole, the information is not destroyed. It is transformed and written onto the boundary in a form that is, in principle, permanent. This is the system with perfect memory. If our Big Bang was the other side of such a shredding event, then every star Webb sees, every galaxy it maps, and every impossible black hole it discovers is a piece of a shredded document from a parent universe that we are only now beginning to piece back together. We are not looking at the beginning of our universe. We are looking at the pile of strips left by the birth of a new one. This horror of scale forces us to realize that we are standing at the threshold of the fourth zoom. Just as we realized Earth was not the center of the system, we are now realizing that our Big Bang was not the center of time. It was a local event, a big bounce or a handoff from a previous universe to ours. The cosmological principle that assumed the universe was the same everywhere was a local map for our lagoon, but we have now discovered the parent ocean that birthed the lagoon. Webb is showing us that the monsters in the dark are the evidence of an eternal cosmic cycle, a dance of destruction and rebirth where energy is carried forward from one eon to the next. The Hawking points, those mysterious circular hotspots in the cosmic microwave background, are the fingerprints of supermassive black holes from a universe that existed before our own. They are the last whispers of a previous cosmos quietly etched into the sky. By framing the Webb discoveries through black hole cosmogenesis, we solve the grandparents before parents paradox that has paralyzed standard cosmology. The galaxies are mature because they were seeded, the black holes are massive because they were inherited, and the timeline is broken only if you assume our universe is the only one that ever existed. We are living inside a holographic womb, a 3D projection of a 4D reality that exists outside our bubble. This isn't just a different universe, it's a different kind of universe, one that functions as a memory storage device for a larger metastructure. The scientific community remains quiet about this, not because the theory is fringe, but because the math is increasingly pointing in this direction while our labels remain stuck in the 20th century. We name the unknown dark energy or dark matter to hide the fact that we are looking at the plumbing of a multiverse. But the James Webb Space Telescope has opened the wall to fix a leaking pipe in our model, and it has found a second plumbing system running parallel to our own. We did not go looking for the parent universe. We opened the wall to fix the galaxies, and the parent universe was already there. We are the species that built a $10 billion eye to look at its own birth, and the image it is sending back is a warning. The womb is much larger than we thought, and the Big Bang was only the first breath in a much longer and more terrifying life. This is Chapter 7 of The Reckoning. We have found the fossils, we have heard the chemical ghosts, and we have measured the vacuum catastrophe. Now, we have seen the parents of the universe, the supermassive black holes that arrived before the dawn. They are the final proof that the operating system of our reality is just a sub-program in a larger machine. The next chapter is not about how the universe grows, but about the holographic shredder and the realization that space itself might not be real. We are moving from the what to the why, following the data through the seams of a reality that is refusing to stay inside the box we built for it. The silence where the answer should be is getting louder, and it is sounding more and more like the roar of a black hole's singularity. If you were to take a pair of scissors to the fabric of reality, you wouldn't find a void on the other side. You would find that the fabric itself never existed in the first place. This is the moment where our investigation moves from the what of impossible galaxies to the where of space itself, and the answer is far more disturbing than a few broken equations. We have spent centuries treating space as a container, a vast, silent stage on which the stars play out their lives. We assumed space was the fundamental background of everything, the ultimate given of existence. But the James Webb Space Telescope is returning data that suggests space is not a container at all. It is a consequence. It is an emergent property, no more fundamental to the universe than the temperature of a room is fundamental to the air molecules within it. We are beginning to realize that if the James Webb Space Telescope is seeing seams in reality, it is because we have reached the limit of the quantum glue that holds our specific version of space together. To understand this horror of scale, we have to look at a thought experiment published in 2010 by physicist Mark van Raamsdonk, a proposal that has quietly become the most structurally strange result in all of theoretical physics. Van Raamsdonk asked us to imagine two separate quantum systems, which he called A and B. In the framework of the holographic principle, these two systems correspond to two different regions of space. He proposed that if you make these two systems maximally entangled, meaning their quantum states are perfectly linked across the void, you create a connected spacetime between them. They are not just correlated, they are physically bridged by the geometry of space itself. But then comes the terrifying part of the experiment. If you slowly reduce that entanglement, if you begin to dissolve the quantum link between those two systems, the geometric bridge between them begins to change. It gets longer, it gets thinner, and it begins to fray. If you reduce the entanglement to zero, the bridge doesn't just become very long, it disappears. The two regions are no longer geometrically connected. There is no empty space between them. There is simply no space between them at all. This reveals a reality that sounds like a nightmare. Space is not a stage, but a consequence of quantum correlations. If you remove the entanglement, you do not get distant space. You get a universe where the concept of apart no longer has a meaning. This is the holographic shredder. Space-time geometry, the curvature that holds our galaxies together, that bends light, and that defines every distance we have ever measured, emerges from physics happening on a boundary we cannot see. We are living in the bulk, a three-dimensional projection of two-dimensional data etched onto the boundary of the universe. This is why the discoveries of the James Webb Space Telescope are so shattering. If Webb is finding galaxies that mature too fast or a universe expanding at conflicting rates, it might be because the quantum glue of our local patch of the universe is different from the universal values we assumed. We assumed projection was uniform, but we are starting to see the pixelation where the entanglement is weaker or configured differently. The horror lies in the realization that space is like temperature. Temperature is real, it is measurable, and it can kill you, but it isn't fundamental. It is a macroscopic description of the collective behavior of billions of particles. If you describe each particle individually, the concept of temperature vanishes. It only emerges when you zoom out. Physicists like Juan Maldatena show through the ADS/CFT correspondence that gravity and the space it inhabits are the same way. They are emergent. We've spent the last century trying to fix the container when we should have been looking at the code that generates it. This is why the title "This Isn't Our Universe" resonates so deeply with the data. It means the universal descriptions we wrote were actually just local maps for a single lagoon of entanglement. We are the species that built a $10 billion mirror to look at the beginning of time, only to find that the medium we exist in is not a given. If space is emergent, it explains why the James Webb Space Telescope is seeing impossible fossils and chemical ghosts. If the entanglement glue was stronger in the early universe, then matter could clump, stars could ignite, and galaxies could mature at speeds that are impossible under our current local understanding of gravity. We are looking at a different rendering of reality. This leads us back to the vacuum catastrophe, that 120 order of magnitude discrepancy between the energy we predict in the vacuum and the energy we see. In a holographic universe, that error isn't a failure of math. It is a sign that we are measuring the rendering cost of space itself. The energy of the vacuum is the energy required to keep the entanglement bridge open. If that energy drifts, as the DESI data now suggest it does, then the very distance between galaxies is not a fixed physical reality, but a shifting byproduct of a deeper quantum negotiation. This brings us to the most unsettling implication of the holographic shredder. The universe is a system with perfect memory. When matter falls into a black hole, it was once thought the information was destroyed, but we now know it is written onto the boundary in a form that is, in principle, permanent. The universe never forgets, it only scrambles. Black holes are not graves, they are the ultimate shredders that preserve the memory of everything they consume in a format that is currently incomprehensible to us. If space is emergent from this information, then the James Webb Space Telescope is essentially performing a forensic audit of a shredded document. It is looking at the pile of strips left by the Big Bang and trying to reconstruct the original book of the parent universe. We are living inside a question that is too beautiful to leave unanswered, but the answer requires us to give up the one thing we thought we could trust: the ground beneath our feet. If space is not a container, then our motion through it, our distances within it, and our history across it are all local approximations of a deeper, non-spatial reality. We are like characters in a video game who have finally built a telescope powerful enough to see the seams in the sky, realizing for the first time that our world is a projection. The seams are the places where the quantum correlations are shifting, where the glue is different, and where the universal laws of physics finally reveal themselves to be nothing more than the local settings of our specific bubble. As we follow the data from the James Webb Space Telescope, we are forced to confront the fourth zoom. Just as Copernicus showed us the Earth moves, and Hubble showed us the Milky Way is not alone, Webb is showing us that space itself is not fundamental. We are moving toward a reconceptualization of reality that is as radical as the shift from Newtonian mechanics to general relativity. The holographic shredder tells us that the universe is not made of matter and energy existing in space. It is made of information and entanglement, and space is just the shadow those things cast. We are standing at the threshold of a reality where here and there are just different degrees of quantum linkage, and where the impossible galaxies of the early universe are the first clear evidence that the shadow is changing. The James Webb Space Telescope has not just found something we can't explain, it has found the limit of our current way of explaining anything at all. If space is an emergent consequence of quantum glue, then our entire history of physics, from the Hubble constant to the expansion of the cosmos, is a study of the shadow rather than the object. We are the species that's built a mirror to see its own origins, and that mirror is showing us that the stage was part of the play all along. The silence of the early universe is not an absence of data, it is the sound of a paradigm shifting, a signal that we must stop asking how galaxies move through space, and start asking how space moves through the galaxies. This is the end of the container delusion, and the beginning of our life as a projection in a universe with perfect memory. The shredder has left us the pieces. Now we must find the courage to read them. Imagine a combination lock with 26 independent dials, each one running from 0 to 1 trillion. To open the lock and reveal the prize inside, which in this case is the existence of complexity, stars and you, every single one of those 26 dials must be set to a specific, precise value. Not approximately, not within a generous range, but exactly. The probability of hitting the right combination by random chance is a number so small it has no useful analogy in human experience. Yet as we look out through the mirrors of the James Webb Space Telescope, we are realizing that our universe arrived with its combination already dialed in from the very first moment. These 26 numbers, known as the fundamental constants of physics, define how reality works at its most basic level, from the speed of light to the mass of an electron. If you were to shift the strong nuclear force by just 2% in either direction, protons could no longer bind into nuclei, chemistry would stop at hydrogen, and there would be no stars, no heavy elements, and nothing that thinks. If you increase the cosmological constant by just a few hundred times its observed value, the universe would have expanded so violently after the Big Bang that matter would never have had the chance to collapse into galaxies. We live in a universe that appears to be fine-tuned with a precision that random chance cannot explain. And as Webb finds impossible galaxies that matured far too fast, we are forced to confront the most unsettling theory in the law vault, the idea of simulation instability. The mystery of the fine-tuned constants suggests that the universe is not a random explosion, but a system that follows a specific, optimized code. This isn't just a philosophical debate, it is a direct observation of the dials that permit our existence. For instance, if the ratio of the electromagnetic force to gravity were shifted by 1 part in 10 to the 40th power, stars would either burn through their fuel in millions of years rather than billions, or they would never ignite at all. Change the mass of an electron by a few percent, and the chemistry of DNA becomes impossible. Change Planck's constant, and atomic structure itself dissolves. We are the species that built a $10 billion eye to look at its own origins, and the data it is sending back is making us wonder if the 26 dials were not set by laws, but by a rendering engine that is now starting to fail its own internal consistency checks. In 1953, the astronomer Fred Hoyle looked at the abundance of carbon in the universe and worked backward to a terrifying conclusion. He realized that for carbon to form inside stars, there had to be a very specific, almost impossible, nuclear resonance state that enhanced the reaction rate. He didn't calculate this from existing theory. He inferred it from the fact that we are here to observe it. He told experimentalists exactly what energy level to look for, and they found it at almost the exact predicted value. This was a number derived solely from the premise that the universe must permit the chemistry that produced us, suggesting that existence itself constrains the physics of the universe. This observer-centric reality is where the simulation instability theory finds its footing. If the universe is a simulation, then the impossible galaxies Webb is finding are not a failure of our star formation models, but rendering artifacts in a local patch of the multiverse. We have discovered galaxies like JADES-GS-Z11 and the universe breakers that sit in a slice of time just 330 million years after the Big Bang, yet they are fully formed, massive, and mature. To achieve this mass so early, these galaxies would have had to convert nearly 100% of their available gas into stars, a feat that violates every understood law of gravity and radiation pressure. In our local physics, that efficiency limit is a hard 10%. These galaxies are running at 10 times the expected efficiency, behaving like a factory that produces a finished product with zero waste, zero defects, and zero downtime. Within the framework of simulation instability, this looks like the code is cheating to ensure the observer's timeline is met, even if it breaks the local rules of physics to do so. But a simulation that has to cheat to maintain its narrative eventually runs into consistency checks that it cannot pass, and that is exactly what the Hubble Tension represents. We have two different methods of measuring how fast the universe is expanding, and they have arrived at two different answers that are both correct within their own frameworks. One team looks at the faint glow of the Big Bang and predicts an expansion rate of 67, while another team looks at the stars today and measures 73. The James Webb Space Telescope was sent to settle this disagreement, but instead it confirmed it. This 9% gap is a catastrophe for modern cosmology because it implies that the universe we are measuring is not a single unified system. It is as if two different versions of the simulation are running at once, and they have drifted apart. Nobel laureate David Gross has stated that we should no longer call this a tension. We should call it a crisis. This crisis is the moment where the operating system of our reality, known as lambda CDM, is starting to crash. Consider what happens when a computer's operating system has a hidden flaw. Every application runs normally, every file opens, and every calculation completes until one program makes an unusual request that the OS was not built to handle. The crash doesn't look like an OS failure at first. It looks like a problem with that one program. You reinstall the program, but it crashes again. You try a different program that makes a similar request and it crashes too. At some point, the crashes stop pointing at the programs and start pointing at the foundation. Lambda CDM is our cosmic operating system, and Webb is the program making the unusual request for massive early galaxies and conflicting expansion rates. The OS was built on the assumption of homogeneity, that the universe is the same in every direction. But the discovery of the Hercules Corona Borealis Great Wall, a structure 10 billion light-years long, proves that the ground we built our physics on is not level. We are redrawing the map because the rendering engine is no longer able to hide the seams. The most haunting piece of evidence for this instability is the discovery that the constants we thought were fixed might be drifting. The Dark Energy Spectroscopic Instrument, or DESI, recently conducted a census of 6 million galaxies and found that dark energy, the force that makes up 68% of the universe, appears to be changing over time. It is not a fixed cosmological constant. It is weakening as the universe ages. If the steel of our vacuum is changing its tensile strength over time, then every projection we have ever made about the fate of the cosmos is wrong. We were writing the final chapter of the universe based on a number we misread. This drift suggests that the 26 dials are not permanent laws of nature, but local variables that can be adjusted or corrupted over eons. It confirms the title's most radical claim: this isn't our universe. It is a local patch of a much larger, more unstable metastructure. This horror of scale forces us to confront the possibility that we are not the masters of our reality, but the beneficiaries of a highly specific set of initial conditions that are now beginning to unravel. We are like characters in a video game who have finally built a telescope powerful enough to see the pixelation in the sky. We see the little red dots that harbour supermassive black holes appearing far too soon, objects that mimic the brightness of 10 times more stars than they should have, acting like spotlights mounted inside lanterns to inflate their apparent maturity. Even after we correct for these deceptive objects, the universe still contains twice as many massive galaxies as it should. The stars formed faster, the chemistry evolved quicker, and the structure grew more complex than the rules of our simulation should allow. We are living through what scientists call the fourth zoom, a realization that just as the Earth isn't the center of the system, and the Milky Way isn't the center of the cosmos, our local laws of physics are not universal. We have found a lopsided cosmos that refuses to stay inside the box of our standard model. The vacuum catastrophe, the 120 order of magnitude gap between our quantum math and our cosmic observations, is the ultimate proof that the rendering cost of our reality is something we have fundamentally misunderstood. We named the unknown dark energy so we wouldn't have to fear it, but Webb is showing us that the darkness is far more active, far more wrong, and far more unstable than our labels ever allowed. As we stare into the silence of the early universe, we are noticing that the great filter, the thing that explains why we don't see other civilizations, might be the very instability we are now measuring. The more habitable the universe appears, the more dangerous our position becomes, because it means we are closer to the seam, where the consistency checks fail. We are the species that argued over whether reality's expanding at 67 or 73, publishing papers and convening conferences, while the photons arriving from 13 billion light-years away were trying to tell us that the map was only ever for our street. The James Webb Space Telescope has revealed that the universe is bigger, older, stranger, and more intricate than the picture on the box. The 26 dials were not a coincidence. They were the combination lock that allowed us to exist long enough to build a telescope to see them. But the instability of those dials, the drift of dark energy, and the impossible fossils of the early universe suggest that the simulation is reaching its limits. We are standing at the end of an era of precision and entering an era of a great cosmic reckoning, where we must stop asking how the galaxies move and start asking who or what is running the engine. The silence where the answer should be is getting louder, and it is the sound of a paradigm shifting into a reality we cannot yet imagine. We are living inside a question that is too beautiful to leave unanswered, even if the answer is that the universe we called our own was only a temporary, local exception to a much darker and more chaotic global rule. The next version of the map is going to be stranger than anything we have drawn so far, because it'll finally include the rendering artifacts of a cosmos that is refusing to stay universal. We have reached the end of the map. After following the light across 13.8 billion years of void, through the impossible maturity of the first galaxies, the chemical ghosts of ancestor stars, and the 120 order of magnitude failure of the vacuum energy, we are standing at the threshold of a final reckoning. We are the species that built a $10 billion mirror to look at the beginning of time, only to find that the beginning does not match the model we wrote for it. To understand why this moment is not a failure of science, but its most profound evolution, we have to look at the history of our understanding as a series of great magnifications, a process of zooming out that has repeatedly shattered our most comfortable assumptions about reality. The first zoom occurred in 1543, when Nicolaus Copernicus published a book arguing that the Earth moves around the Sun. It was a realization that cost us our central position in the cosmos, but it gave us Newtonian mechanics, the first mathematical description of the universe. The second zoom arrived in 1924, when Edwin Hubble looked through the 100-inch Hooker telescope and realized the Milky Way was not the total sum of existence, but one galaxy among 2 trillion. This magnification gave us the architecture of the expanding universe and the Big Bang. The third zoom was the adoption of the cosmological principle, the assumption that we occupy no preferred location, and that the universe is the same everywhere at large scales. This provided the ground for the standard model, lambda CDM, which for 30 years explained the cosmos with a level of precision that was the envy of every other field in physics. But we are currently living through the fourth zoom, and at this magnification, the house itself is shrinking. Just as Copernicus showed us the Earth was not special, and Hubble showed us the galaxy was not alone, the James Webb Space Telescope is now showing us that our physical laws are not universal, they are local. We have moved from the what to the where, and the data is forcing us to accept that the universal description of reality we spent a century writing was actually just a local map for a single lagoon. The viral framing, "This isn't our universe," traces back to this specific realization. When a Nobel Prize winner like John Mather says those 4 words, he isn't speaking in metaphors or offering a philosophical provocation. He is making a statement about the data. Mather spent 20 years certifying the foundation of cosmology, measuring the cosmic microwave background with such precision that there was no statistical room for doubt. For him to say, "This is not our universe," is not a critique from a competitor. It is a confession from the building inspector who signed off on the foundation and is now watching the load-bearing columns crack. The crisis we are witnessing, the Hubble tension, the universe breakers, the drifting dark energy, is the sound of that foundation shifting. We have 2 verified measurements of the same universe that give 2 different answers for the expansion rate, a 9% gap that refuses to close even as our instruments become perfect. We see galaxies like the Big Wheel and JADES-GS-Z11 that are too mature for the time they occupy, looking like fully formed mansions in a construction site where the concrete hasn't even dried. We find the Hercules Corona Borealis Great Wall, a structure so vast it violates the cosmological principle that the universe must be smooth. If the cosmological principle is a false foundation, then we aren't just adjusting a model. We are reconsidering whether the design was ever applicable to this site at all. Think about a cartographer who spends 40 years mapping a single continent with extraordinary precision, verifying every road and river. Then he sees a satellite image and realizes his continent is just one landmass among 7 in an ocean he never measured. His map was not wrong, it was local. Lambda CDM is that map. Within our observable sphere, our physics is accurate, and our equations work, but those equations may be silent about everything else. The 4th zoom reveals that we have been doing physics with a sample size of 1. Everything we know about the universe is true inside a boundary we cannot cross. Describing a region we have no reason to believe is typical of what lies beyond. If inflation is eternal, then our universe is merely one bubble in a self-reproducing multiverse, where the 26 physical constants, the dials of reality, are set differently in every patch. Our laws are the laws of this address. This isn't our universe in the global sense, it is merely our local address, governed by a quantum glue that might be different just one bubble over. This realization transforms the vacuum catastrophe from a math error into a signpost. The 120 order of magnitude discrepancy between our quantum math and our cosmic observations is likely the rendering cost of our specific patch of space. If space itself is emergent, a consequence of quantum entanglement rather than a fundamental stage, then Webb is finally sensitive enough to see the seams where the projection begins to fail. The anomalies are not errors in the universe. They are the signals that the map has reached its limit. We are living inside the fracture, the period between the death of an old answer and the birth of a new one. We are like a structural engineer who has found cracks in 4 load-bearing columns on the same day. We have stopped asking what is wrong with the columns and started asking what is wrong with the ground they stand on. The standard model, Lambda CDM, has served as the operating system for 30 years, and it is currently crashing because it is being asked to process data it was never built to handle. This isn't a failure of science, it is science operating at its absolute boundary. We are the species that notice the silence of the stars and the great filter. And now we have noticed that even the constants of our reality may be drifting. If the universe is a system with perfect memory, as the holographic principle suggests, then we are currently performing a forensic audit of a shredded document from a parent universe, trying to reconstruct a book of infinite size from the few strips of light we can catch in our mirrors. There is something both absurd and magnificent about our position. We are a species on a small rocky planet, orbiting an unremarkable star, using mirrors and mathematics to argue about whether reality is expanding 6% faster than it should be. We are genuinely upset about 67 versus 73, and we point $10 billion instruments at the faintest points of light to find the truth. We collect photons that have been travelling longer than the Earth has existed, just to feed them into equations that tell us our map is incomplete. In the end, the phrase, "this isn't our universe," is the ultimate acknowledgement of our own growth. It means the universe is bigger, older, stranger, and more intricate than the picture we drew on the box. The universe is not broken. Our map of it is simply reaching its final zoom. We are standing at the threshold of a new version of reality that will be stranger and more beautiful than anything we have imagined so far. We are living inside a question. It is a question that the previous generation of telescopes was not precise enough to even ask. And as the data continues to arrive and the silence where the answer should be gets louder, we find ourselves driven forward by a singular, persistent human instinct. We will find the resolution, not because the answer is easy, but because the question is too beautiful to leave unanswered. You've been watching This Isn't Our Universe. James Webb found something we can't explain. Don't forget to like and subscribe.